Welcome everyone to our presentation on electrical power generation, a part of Chapter 3, Sustainable Technologies. Power generation, the process of converting energy from various sources into electrical energy, is a cornerstone of our modern society. Whether powering household appliances, driving industrial machinery, or enabling digital technologies, electricity is an integral part of our daily lives. We have several methods of power generation, each with its own strengths and drawbacks. These range from traditional methods such as coal and natural gas, which are effective but environmentally harmful, to nuclear power, which is efficient but poses safety concerns. Recently, renewable sources like wind, solar, and hydropower have gained traction, providing a more sustainable way forward. In this presentation, we'll delve deeper into these methods, the technologies they use, and their impact on our society and environment. Understanding electricity generation is fundamental not just to appreciating the comforts of modern life, but also to tackling the global challenge of climate change. Thank you for joining us on this journey of exploration and learning. Coal and natural gas are both fossil fuels used widely in power generation. They work on the same basic principle, burning the fuel to produce heat, which converts water into steam, and this high-pressure steam drives a turbine connected to an electricity generator. Coal-fired power plants have been a dominant source of power generation for many years. They are cost-effective and reliable, with a significant amount of coal reserves available globally. However, they are the largest source of carbon dioxide emissions, contributing significantly to global warming. Additionally, coal burning releases harmful pollutants like sulfur dioxide, nitrogen oxides, and particulates, which have detrimental effects on air quality and human health. Natural gas power plants work similarly but burn natural gas instead of coal. They emit about half as much carbon dioxide as coal plants and fewer pollutants, making them a cleaner option. However, natural gas is primarily methane, a potent greenhouse gas. Its extraction and transportation can lead to methane leaks, further contributing to climate change. Plus, like all fossil fuels, natural gas is non-renewable, so it will eventually run out. In summary, while coal and natural gas power plants are reliable and effective, they pose serious environmental and health challenges due to their emission of greenhouse gases and other pollutants. Next, let's have a look at nuclear power generation. Nuclear power generation is a method of producing electricity by harnessing the energy released from nuclear reactions. It's a complex process that involves the use of uranium or plutonium in a nuclear reactor, where the atoms are split in a process known as nuclear fission. This process releases a large amount of heat, which is then used to produce steam that drives a turbine connected to an electricity generator. Among the advantages of nuclear power generation are: 1. High energy density. Nuclear power has a higher energy density compared to other forms of energy. This means that a small amount of nuclear fuel can produce a large amount of energy. 2. Low greenhouse gas emissions. Nuclear power generation produces virtually no carbon dioxide or other greenhouse gases, making it a clean energy source in terms of carbon emissions. This is particularly important in the context of climate change. 3. Baseload energy. Nuclear power plants can provide a stable, constant supply of electricity, known as baseload power. Unlike renewable energy sources like wind and solar, nuclear power doesn't depend on weather conditions. 4. Abundant fuel supply. The supply of uranium, which is used as fuel in nuclear reactors, is abundant and can last for many years. However, there are some drawbacks of power generation as well. Some of them are: 1. Radioactive waste. The biggest drawback of nuclear power is the production of radioactive waste, which remains hazardous for thousands of years. Managing and disposing of this waste safely is a major challenge. 2. Risk of accidents. While nuclear power plants are designed with numerous safety systems, there's always a risk of accidents, as seen in the Chernobyl disaster in 1986 and the Fukushima Daiichi nuclear disaster in 2011. These accidents can have devastating environmental and health impacts. 3. High initial costs. Building a new nuclear power plant is expensive and time-consuming. It also requires rigorous safety and environmental impact assessments. 4. Limited fuel supply. While uranium is relatively abundant, the supply is not infinite. The extraction and refinement of uranium also have environmental impacts. 5. Potential for weaponization. The technology and materials used in nuclear power can potentially be used to produce nuclear weapons, which raises security concerns. In conclusion, while nuclear power has significant advantages, particularly in terms of its low greenhouse gas emissions and high energy density, it also has serious drawbacks, including the production of radioactive waste and the potential for catastrophic accidents. The decision to use nuclear power is therefore a complex one that requires careful consideration of these trade-offs. Renewable energy refers to energy that is collected from resources that are naturally replenished on a human timescale. These include sunlight, wind, rain, tides, waves, and geothermal heat. Renewable energy often provides energy in four important areas: electricity generation, air and water heating and cooling, transportation, and rural, off-grid energy services. Renewable energy is crucial for sustainability for several reasons. 1. Reducing greenhouse gas emissions. The most significant benefit of renewable energy is its role in reducing greenhouse gas emissions. Traditional energy sources, such as coal, oil, and natural gas, release carbon dioxide and other greenhouse gases when burned for energy. These gases trap heat in the atmosphere, leading to global warming and climate change. In contrast, renewable energy sources like wind, solar, and hydroelectric power generate energy without emitting greenhouse gases. 2. Infinite supply. Unlike fossil fuels, which are finite and will eventually run out, renewable energy sources are infinite. The sun will keep shining, the wind will keep blowing, and the rivers will keep flowing. Harnessing these infinite energy sources means we can rely on them to meet our energy needs indefinitely, contributing to our long-term energy security. 3. Energy independence. Relying on renewable energy can increase a country's energy independence. Countries that lack fossil fuel resources must import them from other nations, which can lead to economic and political vulnerabilities. By investing in renewable energy infrastructure, countries can produce their own energy locally. 4. Job creation. The renewable energy sector can create jobs. These range from jobs in renewable energy production, example, solar panel installers, wind turbine technicians, to jobs in areas that support the renewable energy industry, example, manufacturing, transportation, and construction. 5. Public health and environmental benefits. Renewable energy sources produce little to no emissions that harm air quality. This contrasts with fossil fuels, which release pollutants that can lead to a wide range of health problems, from asthma to cancer. By reducing these emissions, renewable energy can lead to cleaner air and healthier communities. In conclusion, renewable energy plays a critical role in sustainable development. It allows us to generate power without compromising the health of our planet or its people, and without depleting resources for future generations. It's a key part of strategies to mitigate climate change, create economic opportunities, and reduce reliance on fossil fuels.